today we'll discuss a problem called vertical order traversal of a binary tree. So, yeah, I think the best way to explain the requirement of the problem is directly going to a diagram and explaining it in the diagram. For example, we have an input, right? So the input is given here, which is like we have a set of input of nodes, which basically defines the kind of binary tree that we have. I think this is probably level order traversal, right? So if you do, if so this is a level order traversal of the tree. So first we put the root, and then in the next level we have 9 and 20, which is given here, 9 and 20, right, in the next level. And then in the next level we have like the left and right children of 9, which is basically null, right, and then and followed by the left and right children of 20, which are 15 and 17. So you can see 15 and 17 here, right? So this is a level order traversal of a tree. This is an input. We don't need to really worry about how the input binary tree is made. That is already taken care of. All we need to worry about is writing a function to solve the problem which is in hand. So let me now explain the problem. So the problem is, given a binary tree, we have to kind of print in a particular order. The order being the leftmost column, as you can say. So for example, if you construct a zero column, if you take 3 as having zero column, we move leftward from 3 and then reach 9 here. So that here the column number is -1, right? And then similarly for 20, the column number will be 1 because it is on the right. And then if you go further right, which will be the right child of 20, and then we'll get a column number of 2, right? And here also we can see the row numbers. So basically, row number is basically nothing but the level number. So the 3 you can see corresponding. I mean, near 3 we have this pair 0 0. The right value of this pair is basically denoting the level number or the row number, right? So obviously, as you move down, the level number or row number would decrease. And now, how would we like to print the answer? We have to print the values which have the lowest column value or the leftmost values, right? So leftmost column values we have is only 9. There are no other values with the same column value as 9 in this particular example one tree. And then for the rightmost we have like 20, and then 20 has a column value of 1, and then 7 has a column value of 2. And then for column 0 we have like two values, 3 and 15, but we need to put 3 first because it has got a lesser row, right? And 15 later because the low number for 15 is kind of higher, which is 2, right? I think I have to correct myself. The row number is given by, or level number is given by the first value of this pair. So all of these numbers have a pair written on the side of it, and the first value of the pair gives the level number, and the second value gives the column number. Okay, so there was a slight mistake from my end. This is a call for correction. So okay. So now once we know this information, so there is one more edge case which can come here. So the edge case is this. Because in other cases, for this case, it's pretty straightforward on how will you print the answer. You'll go with the leftmost column, which is 9. You print it here, right? 9 is getting printed here. And then you go for the column which is to the right of it, which is basically 0 number column. And that has got two values, but you need to put 3 first because 3 is of a lower row value or level value. So 3 will become first and then followed by 15, and then for the rest of the columns it is pretty straightforward because each of the Joes have only one element contained in them. So this this explains how we are getting at this output given the input binary tree. For the next question, again it is evident the only point of discussion which is different from the previous question. I mean only edge case is if you consider column number 0 here, we have two items having the same row and column number. I mean, they are on the same level and they're also on the same column. So which one should we print first? Then we have to basically sort the elements. So if such a situation arrives, then we also have to sort the elements and print the elements in sorted form, right? For example, here we have 5, 6, right? Even if we had 6 here and 5 here, we would have sorted and then printed 5, 6 as the answer, right? If in place of 5 there was 6 and in place of 6 there was 5, still the answer would have been same. It would have been 156. So I think I have explained the question and how we'll arrive at the answer as well as the edge cases. Now let us come into how we have implemented the solution. So basically, the solution is done by using a nested loop, in which obviously the first map is the column. The key of the first map is the column number, and the nested map which is contained in the first map has a key as the row number, right? And obviously the vector which is there for the nested map has to be sorted because given a particular given the same row and column, we have to always print elements in sorted manner. So basically the vector which is present in the nested which is which corresponds to every key of the nested map has basically the same row and column, and then that needs to be sorted before printing, right? So okay, so I think this is a lead code hard problem, but you can pretty much see it's pretty straightforward. So let us go into the solution line by line and explain. So we have this result thing, which basically, why is a vector result? Every so result is a list of vectors, and every vector gives the list of elements in that particular column, right? That's why it's vector of vectors or list of lists, right? And then we have the map of maps, which basically is a nested map. The outer key being the uh, column number and the key of the inner map being the row number, and all the elements of the uh, uh, and all the elements corresponding to the key of the nested map gives elements which have the same row and column number, and then that has to be sorted. So it's pretty straightforward. So okay, so I'll come to how this map is getting populated. First, let us come to once this map is populated, how to use this. Okay. So once this map is populated, we'll go through every key of the outer map, which is okay. Sorry, here we are going through in this line we are going through every key of the outer map, and then we have to for this particular key we have to take a vector which basically gives the number of the element list for this particular column, and hence the vector has been named as column result, right? And from the row map we select the second element which will give the vector list having the same row and column, and that has to be sorted because I've already explained just a few minutes back. And then once that is sorted, we have to push it into the column result, right? So this is pretty straightforward. We'll do it for all the keys uh, for the row map which is present in a particular column, right? And then so which is the inner nested map for example, every key of the outer map is points to the inner nested map, and then we have to iterate through all of the keys of the inner nested map, and then basically do this sorting and then populate a vector which gives all the elements of the key corresponding to the outer nested map, which is basically all of the elements corresponding to a particular column, right? So yeah, then once we have all the elements corresponding to a particular column, we'll push it back to a result, because the result is a list of lists where each list gives the number of elements corresponding to a particular column, as I mentioned before, right? Now we have seen that once we have a map populated, how are we populating the result and then returning the result. Now let's look at the second part, which is how are we populating this map, right? So it's pretty straightforward. We basically once a node is we have this base condition. Basically, when the node is null, we do nothing, and then obviously obviously given a row and column, basically that means given a level and column, we push it to the inner nested map, right? I push the value to the inner nested map, and then obviously we recursively call this function, which is vertical traversal. This is basically recursive function in the left subtree and the right subtree. Obviously, for the left subtree, the level would be increased by 1, and the column will be decreased by 1, and from the right subtree again the level would be increased by 1 and the column would be increased by 1. This is for the right subtree, right? So yeah, so this is pretty straightforward, and with that I have explained you the entire solution. And then so in my first part I explained you what the question was and how and then in the second part I explained you like how the solution is, and then we went through the code and discussed each and every line and what it meant. Hopefully you have understood the problem. I'll see you in the next video. Thank you.